as you've already heard, my start was not in space education. My start was in a traditional field of engineering, specifically chemical engineering. I worked in paper chemicals, so worked in paper mills for a few years, and then decided that the life was not for me and that I missed the world of education. And so I went back to school, got my master's in education, and focused on chemistry, since that kind of was a natural shift. But through that experience, I kind of started to think of myself as an explorer. I travel a lot. I like to do adventurous things. And so I wanted to give that spirit to students, because a lot of them haven't necessarily thought about, kind of pushing the bounds, seeing what the rest of the world is like, etc. And so kind of through that, I tried to focus on 3 different realms, which was land, sea, and space. But space always seemed to intrigue the students the most, and where always the most questions came from. And so I kind of dove more into that, and very quickly realized the value and importance of it. And so decided to kind of throw my whole being behind it. And so I ended up becoming a teacher liaison for the Space Foundation, which also actually has Indian teacher liaisons. And kind of through that experience, my mind has been opened up to this greater perspective on the importance of space education, particularly now going into the 21st century. But thank you, SDNx, for having me. I truly appreciate the opportunity to kind of spread this passion and to talk to so many people, particularly people that are across the world. It's one of those interesting things that, having been to many teacher conferences, it's the space conferences that have the widest international representation. And I think that is so important in education as a whole, but particularly something that really can transform our planet going forward. I believe space is for everybody. And it is not just one country that's going to be successful in space. It's going to take quite the international effort to make sure that we can successfully do things that better humanity. So some of you may know many of these things, but this is just a simple graphic to kind of wrap our head around the fact that space is a fairly new thing. It was really only during the 1940s that it began to pick up. Before that was Robert Goddard with his with some of his smaller rockets, but it wasn't until the V2 in World War II that rocketry started to, pardon the pun, take off. And it wasn't until post World War II then that nations, particularly the United States of America and the USSR, that they started to throw really kind of a lot of heavy weight behind developing that technology. Of course, the intention of that was militarily, because those two nations were opposed to one another. But out of that did come the positive of trying to explore space. And of course, you have Sputnik, you have Mercury and Gemini, and then of course you have the Apollo program. You have the Mir space station, et cetera, et cetera. And so, but for a period of time, it was really kind of relegated to the realm of 2 nations, though with some support of other nations as well, until kind of the 1990s, and then certainly into the 2000s, where you begin to see really this much bigger growth of other nations getting involved. So for instance, in the early 2000s, we have both the Chinese and then also in the late 2000s, the Indians, who began to start to really kind of do their own exploring and not necessarily depend upon the technology and the kind of more greater launch capabilities of the United States and now Russia, which is great. And that's really important. Also in the 2000s, you begin to see something that, kind of looked out of the realm of possibility, which was private corporations beginning to fund their own launch vehicles and put their own technology into space. Part of that was partnering with governments, and I think private corporations will always partner with governments. But you also have kind of these corporations that are doing their own thing for profit, and building a strong company that can then grow. So what we've seen through the years, and this is just a simple graphic of kind of trying to point out startups and particularly focused on number of investors. And of course, investing in business creation are kind of go hand in hand. You can't have one without the other. But startup businesses need investors, and they need someone to back them. And so as you see, even in the early 2000s, not a whole lot is happening. And so the global space economy really doesn't start to get this focus from the investment world until start of 2010, but really doesn't pick up for another 2 or 3 years. But then you compare where we are in the present to the last 5-6 years, you're really seeing quite this pickup and growth in terms of the number of places, venture capital corporations, banks, equity, angel investors, et cetera, that are willing to put their money behind this. The important part that this highlights is the fact that it isn't just the so-called space enthusiasts that see value in this. A venture capital firm is going to have a lot of capital behind a whole lot of different industries and companies, not just space. And so the fact that they are then willing to shift some of that money to space startups shows how important and how where they see potential growth for the future. Combined with that, then, once you have a greater growth in people and companies that are willing to invest their money, you then begin to see more startups that begin to form because they see the support that's out there to start doing what they see as having economic value. And so again, you could almost overlay these two graphics and kind of see the growth in both of them. And they happen at about the same period of time. 2010 is where you begin to see more and more startups begin. And then that picking up through the present. And so, I mean, to be totally honest, examples of recently founded startups that have not yet announced their investment, I have not heard of those companies. I know of many. I have not heard of them. And it just goes to show you how small some of these companies start out as, and how that growth, again, dependent upon the investment, is really important. And so as you look through that last decade, you really begin to see quite this boom in the global space economy. And so just in the last 10 years, they've seen around a 72% increase or percent of change in what the value of the space economy is. Now, that's a loose estimate because a lot of places define the space economy as different things. For instance, SpaceX is really more of a launch vehicle company. Now they're beginning to put their own satellites into space, and I imagine there's going to be some internet access that's coming from that soon. You have other places like Firefly, which is a small launch vehicle company, and that's only small launch, like CubeSats and such. So you kind of have this, like, it's hard to parse out exactly what can be counted as part of the space economy. But I still think it highlights a really important fact that in terms of growth, it's quite impressive. And right now, actually, in terms of the year-to-year growth, the space industry is pretty much at the top and on par with biotech. And those are the two top ones. And biotech has been around for a while. Space has not. And so the growth possibilities are quite impressive. Now, just to kind of give a snapshot of what the future could look like, Morgan Stanley did some research really, and this is helpful because it focuses in just on a very specific area of the space industry, which is satellites. Those are definitely in space. We know that's a part of the space industry. So Morgan Stanley estimates that in 2016, the entire satellite industry is valued at just under $400 billion. They predict by the year of 2040, internet access from satellites alone will be over $400 billion, which is just 39% of what they think the total value of satellites will be. So you're talking about a 24-year difference, which isn't a short period of time, certainly, but is not a long period of time. And you're seeing tremendous increase in value. And so both for corporations, which of course want to make profit and grow, but for the people that work for them. And the fact that this booming industry is growing and growing and growing, they're going to need people to do those jobs so that they can grow, so that they can provide services, and in the end, so that they can make money. And so all of these new jobs really require new skills. And if there's any educators out there in the audience, you may or may not have heard of 21st century skills. It's one of those buzzwords in education that kind of gets thrown around a lot. Not going to dive into it too much, but it hits on these 5 main areas, which is critical thinking, creative thinking, citizenship, communication, and collaboration. And those 5 C's really kind of hit on the broad categories of what it takes to kind of do a job in the 21st century. Because even as you and I are interacting, 40, 50 years ago, this was not possible. If I was living then, I would not be talking to people from India. It just wasn't happening unless I physically traveled there. And so the fact that now technology has changed how we live has also changed how we need to think and act and complete our jobs. And of course, that requires a completely different skill set. So there is a problem. And I also do want to do a quick caveat. The research that I have kind of dove into is mainly focused on American education. I would predict that it translates to other places, but it was the easiest place for me to find my research. And as I'm an American teacher, I figured it would be appropriate. But I think the points still translate over to many places. And so the problem is this in America, is that most Americans do see our kindergarten through 12th grade STEM education as being average or below other nations. Now, again, average isn't bad. I would not be happy with hearing below, that's for sure. And that's disturbing. You also have another fact of people seeing a wide range of problems in schools, parents not being involved. That could be for a whole host of things. Life stresses, work. Now we have a lot of two-parent families that are both working, which then puts extra stress on time. Students finding this lack of relatability to education. And I think there's a big a connection between lacking of interest and then also not willing to work hard. And so students want to see value out of their time investment. And sadly, in education, that isn't always very clear, particularly because as we look down further, particularly in the United States, we need to try and show that our schools are doing what they say they're doing. The easiest way to do this is standardized tests. But then too much focus gets put on these tests so that you're more trying to prepare a student for the test and not actually preparing them for what is to come next, which is hopefully post-secondary school, college, university, and then postgraduate school. And so you kind of begin to, as you parse out all of these issues, it's worrying. And really, it's creating what you would call a skills gap. Now, this is just focused on the manufacturing industry, but I felt it was a good graphic to highlight a broader issue, because if just the generalized manufacturing industry is having a problem, the space industry is going to have a problem, and many other STEM jobs are going to have a problem. It may not be perfect to this, but the simple fact that that in 10 years, or now under 10 years, 8 years, it's predicted to have over a 50% gap. That's bad news. There's no way to sugarcoat it. I have a few connections at traditional space industry companies like Lockheed Martin. They're worried too. And in fact, they're incredibly worried. And the industry as a whole is very worried. And they're scrambling to figure out what they can do to fix it, because it's not something you just fix overnight. This isn't just you suddenly convince people that they want to do this. And, when students go to college and progress through high school, they're forming their sense of what their future is going to be. And if you don't get to them early on, they're going to think of something else, and then you're not going to have the workforce in order to do the job that your company's meant to do. So all that being said, Americans do believe in space exploration. They believe that America should be at that forefront. And we are. I mean, we still are. We were one of the first. And it's I believe we can serve as a great leader in doing that. I'm not a huge fan of leader. I prefer leader in partnership. But it's still the fact that we do need to be involved. What's also interesting is that the majority of Americans also believe that NASA should still be heavily involved. I believe that also. But NASA is a government organization. And so I think that also highlights the important fact that governments and industry, private industry, need to work together for this to happen. And it's how that partnership evolves will be interesting. But this isn't, kind of like, I don't know much about the biotech industry, but I see the biotech and pharmaceutical industry is kind of doing their own thing. At least in the United States, they do their own thing. And that's different in space. And so it's going to take a lot of work and talk and working together to be successful for everyone, for private corporations and for governments. So, how do you close a skills gap, produce high quality education, maintain a country's global space leadership, or even just grow your space your space presence, while trying to get parents and families involved, trying to get students interested and putting more effort into school, all at the same time providing the workforce of the 21st century? I chuckle because that's kind of a long list, but I think it's possible. And you can probably guess what I think is possible through space education. I believe that space education has the ability to touch every person, okay? Not just students, but everybody, all constituencies, families, and both small and greater communities up to a country. The simple fact is that space has the ability to inspire and give people passion and interest. Pharmaceuticals don't. But space, gosh, just anything is possible in that. And so if we can get not just students, but their families and communities that support those students, to stay interested in something like space, we can really both give students and families the great career possibilities of a stable, high-paying job, corporations grow, and in general also, space makes everybody's lives better. Internet access, GPS, television, communication. We can go through a whole host of things, including some more far out things that low Earth gravity might provide us. But the simple fact is that we must educate all of those groups if that is going to happen. Now, at my school, I've tried to do that. And kind of through the next half of my presentation, give you a sense of what I'm trying to do. And hopefully you can pick out pieces. And again, I know I'm speaking to a broad range of people. I believe some educators, some students, university, maybe younger, some industry professionals. Hopefully you can see a piece that anyone can either start, get involved with, or if you want, copy. And again, it can start small. It's a small group of people talking about this. Your neighbors, down to just the people that you live near. But it only happens through educating everybody. And so at my school, I've created the St. Mark's Space Program. And so what the goal of the program is, the mission of the program is that it is meant to educate students, faculty, and the broader community on a multitude of topics that are related to space exploration and the aerospace industry. And the goals of that are to provide those students and community members with as many opportunities as possible to engage with space and space-related topics and issues. The simple fact is that no one thinks in the same way. Everybody kind of approaches life from a slightly different perspective. They find different things engaging. Some people read more, some people watch more, some people listen more. Some people just want to hear it directly from a person's mouth. Some people want to are more introverted and want to do things on their own. And so you must provide as many different opportunities to touch on all those different learning styles for people to feel like they can be involved. Now, one of the things that's important, I actually work, so St. Mark's is a private school. We're a private boarding school. So we have a whole lot of entities that are involved in kind of the sustaining of the school. And what I see as important is that the programs support that entire system. And again, this can be translated to even just you and your neighbors, or you and your local community, you in your school, you in your museum, is that hopefully what it does is it supports the purpose of each of those people. And so, of course, students. I mean, you can't have a school without students. So it's meant to support them, and I'll talk about the different ways that I support students. But what I also want to do is support admissions. Once those present students leave, well, we need to get more students. And hopefully those students decide to come here because they see something that's interesting and supporting and fascinating. Of course, talking about those students that just left, they become alumni. And so working with the advancement office to kind of keep them involved in the school. It shouldn't just be this 4 years and you're done. It's a place that you can kind of consistently go back to. And now the last one is the community piece. And I think this is really important because when I talk about community, community can have many definitions. Community can be faculty and their families or students and their families. It could also include alumni. It could also include the local community. Schools that are in the area, elementary schools that are down the road, other high schools, just the general public. And so what I actually kind of think of this as is historically people do see universities and colleges as kind of these apologize for using this word, these beacons of enlightenment, where they have programs that the community can be involved with, open to the public, etc. I think lower schools are also possible of that, and that lower schools can also present those opportunities to share with a large group of people education, and get those people continuing to learn and being lifelong learners that they may not have the opportunity to access. Not every town or city has a major university. Every town and city has a school, no matter what the age of that school is. So how do we accomplish this? How do we kind of involve all the constituencies? Keep on saying, have a hard time with that word. How do we do that through many different programming? So let me walk you through this. It's a little intense. I actually do a lot of this. And some of that is aspirational. Some of it I've not quite gotten into because it takes time. But I think what it does is it serves a lot of people. And of course, again, the major constituency is the students. That's the main group I want to hit this at home on. But what I can also do is involve other people as well in this process. And I have hopes and dreams of kind of expanding it even further beyond this. But for now, these are the groups that I'm kind of aiming at. And so I broke it down into 5 main categories. Now we're focusing on informal education, so education that doesn't necessarily happen in a classroom, public outreach, research, curriculum that does happen in a classroom, and then lastly, partnerships. Partnerships I do want to hit on because, again, this hits at it's for everybody. And so I want to try and partner with lots of schools to get my students talking with their students, to get me, and hopefully some of my teachers, the teachers that I work with, my colleagues, to talk with to other teachers and educators throughout both the country and the world. And so partnerships are important. And it actually starts right under the St. Mark's Space Program. You'll see Patterson Robotic Observatory. This is actually my original idea. My original idea was to build a robotic observatory. And so we have a grant program through an alumni at our school. And he provides some funds for things that involve technology and are basically kind of expandable past the St. Mark's world. So more to outward places. And so this robotic observatory is also remotely controlled. And so it's meant to serve as a resource for both people that are on campus, but people that are off campus. And so it's meant to be open access and schedulable, which means, for instance, if you are in India, well, it's dark outside right now, which means you could, in the afternoon, still be staring at the night sky. Or if, say, for instance, I want to record images at 3 a.m., I don't actually have to be awake at 3 a.m., which I'll take that. And so this was my thought of being more of this larger distance outreach to other individuals. Other places do have telescopes like this, and observatories, Harvard one of them. So it's kind of modeled off that idea with the caveat of it's a partnership. And this isn't just something that people use on their own, but something that we talk and use together. Now, this is a fairly unique setup. I won't go too much into it. It's complicated because it was not a $80,000 setup that usually kind of comes all as one and it's easy to use. It's a struggle. It's been a struggle, but it's all been completed. It's now basically me learning how to use kind of the software that goes along with it, etc. So it's not quite completed in terms of the usage and open access yet, but we'll hopefully soon be there. Diving into kind of the informal and the research perspective. So the informal education, I have the Space Club, and if you kind of go back to that original graphic, you would have also seen the Star Command. My students chose that name. That is my student leadership group. There are 12 students on it, ranging in nationalities and genders. And so they are kind of meant to be the people up front, the students up front that are leading the Space Club and are also getting other groups involved. So I hope that they lead, say, a star party for the local community, not me. Because it's also about empowering students, and when students feel empowered, they're going to let their passions shine through. And that's also a great leadership opportunity for them. Very self-empowering and can stick with you for a while. I also want to form a TARC rocket team. So Team America Rocket Challenge is a national rocket competition. I was meant to start it last year, but through some roadblocks and then, of course, COVID-19, that didn't happen. So we're going to try and do that again this year. COVID barring, we'll see. But essentially, it's similar to a robotics competition team where they have a challenge they need to complete, except it's using rockets. So a great team building exercise while also learning some practical technical knowledge. Research is one that is both currently ongoing, kind of, and then also one that I really want to get into. And so NITARP is a national program that partners educators with NASA research scientists. I kind of want to mirror that a little bit. And so again, using the observatory to collect data and information, because there's a whole host of things that are within reach that normal people can research. You can search for asteroids, you can measure their rotations, you can even do some fairly rudimentary exoplanet research. There's a whole host of data that has been collected and actually hasn't even been processed. So there's lots of research opportunities, both for adults and for students. Now, the STEM Research Fellowship is a student research program on campus where students come up with their own in-depth research. They find a professional mentor, and then they conduct it. They end up presenting at both state and international science fairs. And some have pretty unique research. Not related to space technology. I had a student that won second in the state and then went to international science fair for doing 3D bioprinting with chicken albumin, the whites of a chicken egg. There's been a whole host of different projects. I'm encouraging students to do some space-related ones. And so I had a student, Mo Lu, 3 years ago, who wanted to check on the seed germination rate in a Martian atmosphere. And so she didn't use Martian soil. She basically just focused on the atmospheric pressure and the essentially the gas percentage, the distribution of oxygen and other gases within the Martian atmosphere to see how quickly seeds would germinate. Also, I had a student 2 years ago, Robbie Harper, who wanted to simulate, and I think he actually hit on a really important part, that when we focus on trying for the search of life in the universe, or even just in our solar system, it's really hard to get instruments to places to actually find those things. And so to help narrow down that search, why don't you focus on extremophiles, organisms that can survive in extreme environments, and kind of mirror the living conditions of possible places and see if those things survive. And so he focused on tardigrades and whether or not they could survive in an environment like the subsurface ocean of Enceladus. And so he tried to mirror the alkalinity and saline content of that subsurface ocean, see if they survived, etc. And so it really doesn't have to be astronomical research. There's a ton of space-related areas, space research-related areas that students can really get their hands on and actually do, and then contribute to furthering the field. Public outreach happen in a whole sort of ways. Movie and speaker series are kind of an easy go-to, both happening on campus and off campus. So on campus, I had a professor from Bentley University, an astronomy professor, talk about exoplanets. I had hoped to get astronaut Dwayne Carey last spring. COVID got in the way of that. He was supposed to come, but they had to cancel. I've gotten students off campus into the Boston area and the Worcester area to hear Neil deGrasse Tyson, Michio Kaku, Professor Brian Cox, and astronaut Scott Kelly to hear them speak, which were all awesome. So it's really kind of providing people as many opportunities to hear from individuals that are doing this, which is important. Also, star parties, pretty standard. Take out a whole bunch of telescopes, get people to look up at the sky, be amazed. Pretty much, I can't tell you how many people see the rings of Saturn for the first time and are just blown away. And most people will typically highlight that as one of their first experiences that has a major impact. I also want to run a space conference, both geared towards educators and geared towards students. So two separate ones. The student one I want run by students, and I think that's important. I was hoping to do it this summer. Yeah, that didn't happen. So maybe next summer, we'll see. And lastly, curriculum. And so I have two courses that I teach, Air and Space and then Space Technologies. Air and Space is a very generalized course, and it's not meant to be an astronomy course. I want to hit on the large amount of topics that are related in space. So they kind of get a very large overview of a lot of different things. So we take a look at astrophysics, astrochemistry, astrogeology, astrobiology, the search for life, habitability, etc. But then we also dive into contemporary issues, history, the fact that space exploration kind of started with a Nazi scientist, Wernher von Braun. And what's the ethical implications behind that? We focus on the space industry. We talk about the fact that politics is such an integral part to space exploration. NASA is a government-funded organization. And so they're beholden to what politicians are deciding for budgets and focuses. And how does that interplay with space exploration? And then lastly, kind of talking about the social impacts, ethics, sociology. If we were to colonize somewhere, how does the social interaction, government, structure, population, distribution, how does that happen? And then lastly, another course, Space Technologies, where we focus on units of rockets, robots, and hydroponics. Rockets, I mirror what the TARC competition is. Robots, I mirror what we actually create a simulated Mars environment. We created a crater. Now I'm forgetting which crater we created. It's on the South Pole. And they had to basically redesign their robots to be able to take on that terrain. And then lastly, hydroponics, because that's going to be the only way we get food if we're going to sustain long-term life past the moon or even on the moon. Now, lastly, curriculum can be not just space-specific courses. It can appear in other disciplines. And I truly believe that space can touch on pretty much the full gamut of courses that happen in a school. So for instance, US history, again, going back to the space race, and then of course, World War II, pretty easy. Social justice, just to highlight a point of that is that a few years ago, I think it might've been Reuters, so a news organization partnered with a satellite imaging company and was able to track the movements of modern day pirates that were using slave labor in, I believe, off the coast of Indonesia. And so through that tracking, they were able to provide the Indonesian National Police the information necessary to track them down and capture the pirates and release over 2,000 modern day slaves. And so there's a big social justice component of modern day space. And then lastly, studio art. So art has this important place in my heart, but it also, I think, opens up many people's eyes to both the beauty, but also the possibility of space. And so a lot of the times when you can't see something, it's hard to understand. But artists are in the unique position of trying to get people to see things that they aren't used to seeing. And so kind of through that discipline, you can open people's eyes to what could be there, a different perspective on it, and get you to really think, oddly enough, creatively about something that could actually be there, you could study and understand more. And so a couple of examples of the Studio 2 class. This was actually not of my prompting. This was of a colleague of mine that kind of loved what I was doing and just kind of went off on her own. Students that made Japanese printmaking or Japanese styled prints themed around space. And so I actually kind of like the upper left one because it's where an astronaut from Apollo has landed and he turns back, or he or she turns back and looks at the Earth and sees it fracturing. And of course that can interplay with the world politics, of course now a pandemic, global climate change. It kind of gets you to think about the perspective of what is happening on our Earth, because a lot of the times astronauts that have been in space or been on the moon talk about the beauty of looking back at it. And this is such a unique planet. There is no other planet out there that we know of, and there probably won't be. And how important that is, and how that gives us perspective on the issues that we think as being so important. But in the larger cosmic perspective, maybe they aren't. And maybe we really need to put in more effort into working out those issues. And so let me just end with what a quote from Chris Hadfield, who is I view as my role model, also an astronaut, is that nobody changes the world on their own. The only way to make progress in space is to work together. And not just work together in terms of me and you through international lines, but also through me and others that are close by me, people in my local community. And so if we want to positively impact the future, particularly related to space exploration, we must be willing to work together and also to take the time to educate as many people about it, because that is going to be the best way to make progress and to change the world. And of course, you can't do that without Audere Res Fortes, which is Latin for dare mighty things. We have to dream. We have to think that pretty much the impossible is possible, and we must be willing to take chances in order to do that. Of course, again, together. Thank you. And I believe we have some time for some question and answer, correct?
Hello, Mr. Brady. Yep. So thanks a lot for your share. I think you talked about the skills that one must have to study about this in this increasing space era. So definitely, of individual, if we talk about a school student or a college student, that because we are basically dealing with this kind of age group, right? So they must have the skill set, okay, so that and we are working on that. So it was a nice session and it was really great to hear you. So let's hit for the questionnaire session, and if all the participants are requested, if you guys have any kind of query, so you just unmute your mic or just drop your questions in the chat box.
Let's say I see one question from Aruchi.
Yeah.
How can we connect and learn about more such programs, clubs, communities, webinars, and events related to space from India? I mean, I think, and I don't know about what in terms of internet access, in terms of how different different countries can access material, but For instance, NASA and a lot of other private organizations like the Space Foundation, NASA's Jet Propulsion Lab, Space Center Kennedy, Space Center Houston, all those places have a ton of public outreach and also a lot of free material because, again, NASA is a government organization, and so public involvement is a part of their directive. They must do that. And so that's actually a great place to even just get ideas to start from. It's not necessarily something that is kind of out there and impossible to think of, but that's actually where a lot of things a lot of ideas I've gotten. So that's a good place to start. To be honest, I don't know of many things, organizations in India. SDNx is kind of actually the first one I've known of. So I would suggest just searching out and seeing if there's more. And if not, look for other companies or countries, places in other countries. And that's a great place to go.
Definitely. So internet should be as we can see. So due to the pandemic, most of the centers or most of the institutions, they are not working. Okay, so they have just operating online. So it's online platform is a very it's a kind of a place where you can find anything, everything. Okay, and
Nitin?
Yes, sir. Good afternoon, sir. How are you?
Good afternoon. I'm fine. I think I have one question.
Sure. So first of all, Mr. Brady Sundamurthy, sir, he is a former mission director from ISRO, Indian Institute of Space Research and Technology. So, Indian Institute of Space Research and Organization. So he has a question. He has a question for you.
Great.
Oh, very good morning, Brady. I think you have given the kind of broad outlook for the students, how they can get into the space, and then what are all the possibilities and the venues available. Of course, you have given the all possibilities and other things, but I have one small question for you.
Yes.
That you have given in one of the slide that by 2028 there could be 4.6 million opportunities are going to be there, but in that only 53% it's going to be met. Rest we are still to be filled. I would like to know what is the basis, because as far as I am concerned, there the kind of jobs which are created and then the people are already available to fill the gap. But I see from your slide that it is almost in another one decade there is going to be a 50% of the though the job is available, personals will not be there. What is the basis? I would like to know.
So I basically utilized that graphic just because I think it highlighted the skills gap. The number, so it was based off of a research group. And now let me go back to the organization. It's a research consulting group, a manufacturing consulting group in the United States, Deloitte. And so, I mean, they touch on consulting for a lot of different industries. So I was using what the information that they had collected. I mean, I think what this was geared towards, the U.S. manufacturing industry is a pretty broad industry, around physical materials like steel, automotive, etc. So I think that sounds like a really large number, but you could probably categorize the manufacturing industry as a pretty massive industry. So through that perspective, you are talking about a lot of opportunities. I part of the data is based off of the fact that a lot of those people through those years that might be working in those fields will be leaving to go to maybe other jobs or retiring. And so that's where, and then at the same time, the industry growth is occurring. So not only is the industry occurring, which then requires more jobs, but then you have current employees that are then leaving and leaving behind vacancies. And so that's why the number of position goes up. But if the number of positions goes up because of those vacancies and growth, but say your kind of your pipeline of future employees doesn't grow with it, you begin to create this bigger gap between the two. And I think that's really what it's kind of highlighting, is not that less students are going into STEM fields. It's that the rate of them doing it is not matching what the industry requires. And I also think this is true for the space industry. Like I said, speaking with some individuals at Lockheed Martin, they're worried. They're legitimately worried because they're seeing the growth in the things that they want to do, and they don't see the number of students that are willing to get into that. Now, again, part of this is based off of the fact of America and American students, et cetera. And of course, that becomes a bigger geopolitical issue of, how do you fill those positions if you don't have, say, American citizens that are willing to do it, et cetera, et cetera. More corporations are moving to other countries that have that populace and that skill set to fill those positions. So I think you're right. The issue was kind of glossed over to just kind of highlight the fact that there's a positions gap, a skills gap in terms of those positions. I think you can solve that in many creative ways. But the simple fact is that in America, that gap will more than likely exist, and it's just going to get bigger.
Thank you, Brady.
Of course.
Okay, you have given some sort of a good insight into the requirements, and then how of course, I agree with you. Now, the students who are picking the space is not that much encouraging when compared to the growth what we are seeing. I think in the coming years, I think, yes, I agree with you, the demand is going to increase, but the gap, anyway, I felt it was a little bit on the higher side. Almost you have projected 50%. I thought the gap could be only 10 to 20%. Anyway, it's a good one because I think what I was seeing from the scenario from India, but of course, US, resource was done. So, okay, thank you.
Thank you very much. Great question, though. Great question.
Okay, so I think we have answered most of the question, Mr. Brady, and we think I think we should conclude the session. So it was a wonderful presentation. It was a wonderful session for all of us, and pretty much we have got as sir already told you that we have got an insight. Okay, so where to search and what to study actually. And so anyone having a question? I think I have heard a voice from somewhere. You guys can unmute your mic and ask question to Mr. Brady, or you can just drop it on the chat box. I will read it out for you. I don't think so. They have any message questions because. Okay, so thanks a lot, Mr. Brady, and so you have a great day ahead, and it was nice having you.
Thank you very much. I truly do appreciate the opportunity to kind of spread the word of space and hopefully spark some ideas of how we can kind of keep on trucking ahead with making this a worldwide global thing.
Surely. I think we should conduct some kind of session that means in upcoming days in the future. So we will in touch with you. No issues.
I'd love it. Love it.
All right. Thanks a lot.
Have a great day, everybody.
Sure.